Hi there, this is my review of the TOPDON TS001 thermal camera kindly sent to the channel by TOPDON. I'm not paid for the video, but since I'm allowed to keep it, I mark it as a promotion. For my previous reviews, you know that this doesn't stop me from sharing all my findings with you. The TS001 is of the clip-on type, which means it has no display but relies on your smartphone. It has a resolution of 256 by 192, a 9mm lens with manual focus and a few other things as you can read on the box. It comes in a very nice cardboard box, quite a premium feeling really. Inside is a pouch and an instruction sheet. The pouch is quite a bit bigger and heavier than I expected. You unzip it in the middle to open it. There's quite a bit more in there than just the camera, which explains the size and weight. Something like an all-metal camera mount. And of course the camera. It is really quite tight in the molded compartment and I'm reluctant to pull on the lens, but that's the only way to get a grip. TOPDON should definitely improve this. In the net we have a 60 centimeters or 2 feet USB-C female to USB male extension cable with an adapter for USB-C male to USB-A male. And a cleaning cloth probably for the lens. Eager to learn what to do with a metal mount, I consulted the instructions. But that's just telling you how to get the app, which is for Android and Windows only. The big QR code promises a detailed multilingual user manual, but when going there, all you get is a PDF version of the same instruction sheet that came with the camera. I asked TOPDON and they sent me the manual, so it exists, but they have not yet put it up on their website. Downloading the app called Top Infrared from the Play Store is easy enough. I was slightly appalled by the ratings, apparently very polarized user views. It turns out most were about some need to create an account. TOPDON probably listened to the complaints and there was no need for me to do that anymore. The USB-C port of the camera plugs into your phone, that much is clear. The big problem with that is how far the phone camera is from the infrared camera. That matters if you like to overlay the two camera images to improve resolution. If they are so far away as it's here, there's no chance of a reasonably overlay unless your objects are tens of meters away. So I thought, that's probably why they give you the mount and the USB-C cable. You can move the two camera lenses closer together. The mount clips on a smartphone easily. This is a Pixel 6. As long as it's less than 9 centimeters or 3.5 inches wide, any Android phone will do. Except, as in my case, there are power and volume buttons in the way, and so at least for the Pixel 6, the mount gets you closer, but it's still quite a distance to the phone lens. Trying to get as close as possible to the phone camera, you end up with a contraption like this, which, while it works, looks a little bit ungainly. But I still recommend it because it secures the camera much better, especially if your USB-C port is a bit worn. The overlay results are not entirely convincing. Because of the huge zoom built into the thermal lens, you have to manually zoom and off-center the visual image to a similar extent. I set up this wire loop with the 6 amps going through to have an easy reference and vary the transparency of the visual image, yet at about 1 meter distance there's still quite some offset. I suppose I could adjust it better, but this is so time consuming and fiddly I rather not use overlay. TOPDON lists the TS001 as for mechanical and electrical work rather than home use. Its close relative is the TC001 Plus. From a thermal performance the two are similar, but the TC001 Plus has a much wider view and a second built-in camera for visible light which solves the overlay issue. The key difference is that the TS001 is manual focus with a bigger and zoomed in lens. Yes, manual focus is inconvenient, but I like the flexibility it gives for very close work on PCBs, which is probably my main target area. Looking at thermal issues in the house is nice and it works, but the TS001 is less suited to that in my opinion, as its field of view is just 13 by 10 degrees. That acts like a rather large zoom in, and so taking a thermal view of a whole wall or a door means you have to take it from a fair distance, which is often not possible. This video was taken in what TOPDON calls observation mode, which is why there are no temperature readouts. And yes, this door is in dire need of draft isolation. Observation mode is meant more for outdoors, where you can set up the camera to give you an alert when an object of a specific size that is warmer or colder than the environment appears and/or moves. Alerts for colder objects might be useful for ghost hunters. Although I'm not really into observing or hunting either animals or ghosts, for those that are, I'll cover observation mode more towards the end of the video. A quick look at the specs. Please freeze if you want to study it in more detail. Accuracy is listed as ± 3 degrees Celsius, which is ± 5.4 degrees Fahrenheit, or ± 3%, I suppose, whatever is larger. That's not too exciting, but in reality it's more the relative temperatures that are of importance. One of the features that's sadly missing is a tripod mounting hole. If there's no space for it in the camera itself, that mount that came with it should really have that. I think it might be possible to have the necessary hole somewhere in that thick part in the middle. As it is, we have to be inventive. Let's have a closer look. The two bars sticking out on the rear are padded with rubber that can be pulled apart against an internal spring to a maximum of just below 9 centimeters or 3.5 inches to grab your phone. The front part has two buttons on each side, and pressing either on unclips the front section to allow inserting the camera, which fits snugly enough so there's no rattling around. The lens cap has to be off when fitting the camera lens. It will not go through the gap in the mount. Once in, you can put the lens cap back on. Instead of a phone, I prepared a piece of wood with similar width that I mounted on a tripod. Over time I have accumulated quite some screws and mounts, and this little ball joint thing isn't really necessary, as the tripod itself can provide the tilt and swivel, but it had a nice metal screw sticking out, and that I could just screw into a pre-drilled hole in the wood. It's not going to last forever, but for now this will do. Now all I have to do is to clip the camera with its mount onto the wood. The springs are pretty strong, but better so than the camera falling off. Apologies for the blurriness while I fight the springs. The connection is now done with the USB-C cable, of course, but since the one that came with the camera is rather short, I used the longer one that I had. As test object, I used this overniced 10 MHz reference oscillator board from China that are quite literally burning in for some months now. Eventually I plan to put it into my HP 5334B counter. To make the app interactions easier to film, I decided to use a much larger tablet instead of my phone. I'm using a Huawei tablet that kind of sits mostly unused since Huawei got banned from the Google App Store, but TOPDON makes the app available for download on their website, and it installed on the tablet without problems. When you connect the camera, you can have the app launch automatically or do it manually. Either way, it comes up with a screen. More about the icons on the bottom later. You select Enable Thermal Imaging and you get this window to remind you to set some basic parameters if you want accurate temperature readouts. These are the ambient temperature, the distance to the object, and its emissivity. You can have this screen not come up and just use the defaults, but I prefer to see it. You can always call up these settings and change it later. For now, I click OK and get a default screen with a nice color map and a color bar on the right giving you the scale. The temperature in this image goes from 23-point-something degrees Celsius to about 54 degrees Celsius. You can select to use Fahrenheit if you prefer. The center temperature is shown next to the white cross, and the hottest temperature, which is the red dot on the regulator here on the upper right. But the readout in white on an almost white background is hard to see. I'm going to fix that in a moment. One more thing, as with most thermal imaging cameras, the TS001 periodically closes the shutter to do some calibration. You hear that as a clicking sound and the video pauses for a moment. AutoCal can be turned off completely or done manually to smoother video at the cost of less accuracy in the measurements. The actual PCB is just visible on the left, and so we realize that the thermal image is upside down. That is from the way I mounted the camera, but not to worry, with a few clicks the image can be rotated and now the orientation matches the real thing. By the way, you see some dots under the icons. These are actually the top of words describing the functions, so you don't have to guess or learn the icons. But that worked only on my phone. On the two tablets I tried, the icons are a bit too big and push the writing down below the lower bar. You can scroll the writing back in, but you have to do that every time, and I usually don't bother. Hopefully TOPDON could fix that in another release. This image is actually already in focus because I was using the camera earlier, but normally it would not be. You have to adjust the focus by turning the ring on the camera lens. I'm deliberately putting it out of focus and then back into focus so you get the idea. The false color image may not be to your liking. There are 10 predefined ones to choose, and you can also make your own. Plenty of choices. It's really a question what you prefer or suits the application best. You will notice that in some of these the temperature readouts are much better to see because of the contrast to the background. This one, for example, is one I rather like, but as I said, it's a matter of personal preference. But even if I use the rather colorful default, it's possible to improve the readout visibility. First, the letter size can be changed to be either small, standard, which is the default, or large, or super big as the app calls it. But honestly, there's very little difference to warrant such a superlative term. Yes, it's bigger, but super big? Anyway, that did not fix the problem of the visibility readout on the regulator. For that, I need to change the color. You can use 6 color circles on the screen or the color board above. I just use black here, and now it's possible to read the temperature on the regulator, which with about 56 degrees Celsius or 133 degrees Fahrenheit is the hottest object in view. But what if you wanted to know the temperature of some other part of the board? There's a tool for that. Actually, what you see by default, center and hottest point, is really the fourth icon here and should be highlighted because it's on. That it wasn't is kind of a bug, but nothing tragic. Anyway, using the dot mode, you can now define up to 3 dots to get readouts. If you select more, the oldest disappears. Because I selected some cooler parts, like the big oscillator can, the black readout is not easy to read. This shows that for readouts you will generally be better off choosing a less colorful temperature map. Switching to the line tool does not make the points disappear, but you can now draw in addition up to 3 lines on the screen, and the app will calculate the highest and lowest temperature along the line. And if you use the area tool, you can draw up to 3 areas on the screen, and the app will calculate the highest and lowest temperature in that box. And to get rid of all that, the trash can icon removes all points, lines and areas and their associated readouts. And to get the standard readout back, you need to manually turn that mode back on. Okay, what else can you play with? Here's a quick tour. You can hide the temperature bar if you want. You can change the contrast, but I usually leave it at the default. You can change the brightness, although that seems to be rather make it appear out of focus. I also normally leave that at its default. And you can flip or mirror the image if you want. You can set alerts. For that, I first turn the power to my overnight oscillator off to let it cool down a bit, shown here a little accelerated. So let's define an alert. I used that before, so some values are already there from the last time. I enabled the high temperature alert and set the value to 51 degrees Celsius. I know the top temperature will be in the order of 56 degrees Celsius, so we should expect this to trigger. I turn on the marker feature, which will surround the area causing the alert, and the audible alarm. You can pick from various ringtones. With the selection saved, it's time to turn the power back on. The board has cooled to about 44 degrees Celsius. Immediately that protection diode gets hot, and quite a bit. 65 degrees and more, triggering the alert and the surrounding markers. After a while, the regulator gets hot and the temperature of the diode drops as the oven inside the oscillator box reaches its target temperature and the current is now just for maintaining it. Time to turn the alerts off by disabling it. You can take snapshots of the screen as photos, of course. More settings are available when selecting the two dot icons. The row of 5 options are overlaid on the screen but not included in the recorded image. The options are exactly the same for photos or videos. Useful for photos is the button on the far left, which is a timer that counts down 3 seconds before the photo is taken. If you press it again, the time is 6 seconds, and if you press it again, it turns the timer off. The 3 buttons in the middle are really only useful for video. First is to turn the auto shutter on or off. As the hint shows, the calibration cycle makes the videos jumpy, so you can forego accuracy and turn it off. The next icon does a single calibration cycle manually and is only useful if auto shutter has been turned off. And the microphone button allows you to record sound together with your video. The somewhat mislabeled Learn More icon on the right does not bring up help explanations or help text, instead it brings up more options, namely burst mode and watermark. Burst mode allows doing a number of photos in quick succession, by default 3 with 1 second in between. The watermark allows inserting text into photos and videos, subject, location, time and date. The bottom sample picture shows how that looks. I can, for example, use your favorite YouTube channel name as a subject and it will insert that. There is not much to say in addition about video. It works as you expect. I have not seen anything like image stabilization, and since the TS001 represents a fairly strong zoom, keeping an image of far objects stable is a bit challenging when done from hand. This is probably more an issue in the so-called observe mode, which I'll touch on in a moment. First, over a cup of tea, I need to briefly mention a few things that I forgot in measurement mode. You can make your own personalized color bar if you so desire. It's fairly straightforward, so I just show the setup screen here without spending time doing one. The standard bar is normally dynamically adjusted to span the lowest and highest temperatures found in the image. You can unlock the bar, which now allows you to adjust the highest and lowest temperatures for the bar. Anything higher is just white and anything lower black. You may want to do that to get a finer color definition if you are only interested in a sub-range of the temperature. If you disable the parameter screen, or if you wish to change something when the program is already running, you can tap the little icon on the top right and the parameter screen reappears. As I mentioned already, these parameters define the accuracy of the measured temperature. A good estimate of the distance between the camera and the target is important, as the radiated energy drops by the square of the distance. If the camera is twice as far from the target, the energy seen by the camera drops by a factor of 4. How much energy a target radiates in the first place compared to an ideal emitter of thermal energy, also known as a perfect black body, is expressed with the emissivity. An ideal black body has an emissivity of 1, while normal objects have lower emissivities. Usually the default of infrared cameras and thermometers use 0.95, which kind of works most of the time. The internet is full of tables of emissivities, and the TS001 also shows some examples here. You may notice that at that point I had set the value to 1 from an early attempt to use a self-made black body setup to check the TS001 accuracy, but this video is getting too long already. If you often repeat measurements requiring different settings, you can create additional parameter sets called customized models, which make switching between them faster. The parameter screen is not the only place where useful parameters hide. If you get out of the actual real-time app and select Learn More at the bottom right, you get this screen, which again is not what I would expect given the name. Firstly, this offers the change from Celsius to Fahrenheit, which is surely what at least some of you would rather see. It works just fine, but sorry, my head works in metric and Celsius, so I will switch back. Image calibration is also not what I thought it might be. I'm fairly new to IR cameras and I have not heard about the black spot effect before, so I can't say if that is an issue, but at least it appears that there is a way to fix it should it occur. If you know more about this, please leave it in the comments. At the bottom of this screen is a possibly quite useful tool called Monitor. I have not used it before, so the first thing to do is to generate an image. We get the same choice of dot, line or area. Let's keep it simple and use a dot. Then I need to select where to put that measuring dot. I decide to put right in the middle of my T. Now we are ready to start monitoring. The app now keeps reading the temperatures and plots it on the screen. It's quite wavy because of all the turbulences in the T, which are completely invisible to the eye. Eventually, I would expect a downward trend to emerge as the T is cooling down. I wondered if I can zoom or squash the graph somehow, and it turned out you can. I speed this up a little bit because watching T cool is only slightly more interesting than watching paint dry. After a couple of minutes, the downward trend is clearly visible. I decided that I'd rather drink my tea now than letting it cool more and stop the monitoring. Now if I get into monitor mode, there's something displayed, the recording I just made. Selecting it brings the graph back on the screen together with an export button. Nice, I can get my data in Excel format. Moving it to my PC using a USB cable, and there it is. I don't have Excel on my Linux machine, but LibreOffice Calc is basically the same thing. We have two columns, time and temperature. Unfortunately, TOPDON decided to save the unit degrees Celsius with every value instead of simply in the first row, temperature degrees Celsius. This means all the temperature values are actually text, not numbers, and so can't be processed. However, I can search for the degree sign and the C and do a replace all with nothing to get rid of them. I missed the first one. Let's do that by hand. So with this operation, the temperature values are now numbers and we can analyze them, for example, doing a graph. And there you have it, the same graph. This is a great feature. If only TOPDON could change the way they save the temperature values so we don't have to do this search and replace process. While we're at the topic, there is of course the gallery of photos and videos saved as JPEGs and MP4s as you expect. You can select a photo and export it to Excel. It takes a moment, but finally it's there. And this is how that looks. You get again the temperatures with units, so for any processing you need to apply the same trick I showed earlier. More importantly, this is a raw dump of the image pixel by pixel. You get 256 rows, and after lengthy scrolling you find 192 columns which match the sensor format exactly. I have not done anything with this, but it's very nice to have the option. Finally, I want to briefly mention observation mode. On the top you can switch from temperature measurements to observe, which gives you some hint that the temperature measurements are not supported in this mode. If you wonder what then is it good for, I think TOPDON has created some interesting uses. First, something they call AI recognition. Really? Oh well, the word AI is very overused these days, and I think here possibly as well. Let's select the high temperature mode first. Lacking the great outdoors that observe mode is targeted at, a small toy RAM that I had in my hands for a while will be a stand-in. And there it is. The AI detected the hot area and highlighted it with a blue box. I tried to find a stand-in low temperature ghost and left it in the fridge and even had it stuffed with foil to give it more thermal mass, but ghost detection once again proved to be problematic. Well, it did detect at least part of it, so there's hope for all you paranormal researchers out there. I tested dynamic recognition, but lost the video somehow. I blame the ghost, but accidentally left it active, so we will see the effect anyway. This mode here is target mode, and maybe best is to show the help. It allows you to find the distance to an object. For that you have to select between 4 target types, so the app knows the size. Next you pick one of 3 styles of measurement lines. When you have your object, you align the center of the object with the measurement lines, and then, as shown here, on the top and bottom lines that just frame the target, determine the distance of 20 meters. So let's pick a goat-like object as target type that seems close to my RAM. If this would be real, I would say it looks as if it's further away than 10 but closer than 30, so probably around 25 meters. One of the functions in observe mode goes by calibration mode. Naturally that interested me, but it turns out that this has nothing to do with calibration. I really wonder who came up with these names. This mode simply shows a red and blue dot representing the hottest or coldest points. Moving my toy figure in and out, you can see the blue boxes from the AI dynamic detection that I left running. The red dot on the front feed is hard to see. There is a Windows version with similar functions as the app, but I can't help finding it less refined and capable compared to the Android version. But it does have a similar monitoring function, as you can see on the graph on the bottom of the screen. To get these versions, you can download them from the TOPDON website. I also used this to get the software for the Huawei tablet. I was curious what my Linux machine would say when I plugged the TS001 into a USB port. It detected it, of course, immediately as a video camera and registered the driver for it. And starting a standard web camera app on Linux had no problems in showing an image. It's grayscale, of course, since this is a normal video viewer that has no idea about temperatures and thermal cameras. But as you would expect, there are already pre-programs that do know about those things. I just tried a Python program from Les White here. It's made for a different model, the TC001, and more proof of concept, but it works fine with the TS001 and I find it very promising. It's a great argument for selecting this camera, that it exports its data in Excel and that it's possible to develop alternative software for it. To wrap this up, I quite like the TS001 and I would like to thank TOPDON for sending it in. My main application is using it for electronics and electrical applications for which I find its narrow field of view works great. For other applications like surveying of buildings for thermal leaks, the TC001 with its wider view and autofocus may be better suited. The app is the same for both. If you enjoy my videos, don't forget to like and subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided supporting this channel by becoming a Patreon. Thanks for watching.